So I'm currently restoring this tiny bench vise, and the issue with this vise is the same I had with the previous vises I restored. The movable jaw is completely stuck. It doesn't move anything. I tried to hit it with a punch, aluminium punch right here to get it apart, but it doesn't move a tiny bit. On the previous vise restorations, I used this tool I once made. One plate has 2 threads in it and the other one has just 2 holes. Then you pretty much just screw into these very long screws into these threads, and while tightening them you push these 2 plates apart and therefore opening the vise, removing the movable jaw. Unfortunately, the opening of the throat here is too small, so that these 2 plates don't fit in. Therefore, I can't use them. Maybe I could just mill off a little bit down here to make them fit. Then the issue would still be they only make contact up here where they're touching the jaws. Therefore, if you tighten the bolts, the tool won't just open. They want to tilt like that. Therefore, you have the forces in the wrong direction. So I need to come up with another solution. So my plan right now is to make pretty much the same tool out of this 22mm round stock bar. Cut it in half, drill and tap 2 holes in one side, and drill 2 holes on the other one, and then having pretty much the same. It will look something like this. So on one piece we have the 2 threads in it, and on the other one just 2 holes to center the long screws. And the long screws will just be 2 threaded shafts with 2 hex nuts welded onto them. To split this part into 2 pieces, it is easiest for me to use the parting tool on the lathe. Just looking that I have enough stick out here, clamp it. This doesn't need to be accurate, so I'm just measuring it with the metal ruler, and this will be enough for that job. That's it. Now I'm just going to turn the faces clean and give it a nice little chamfer. So having both pieces ready, it's now time to drill the holes. I've set this screw here as a dead stop, and I will just lay the part inside of the T-slot. It will be well secured. And I'm using the other part in this slot right here. And I will just set my clamp right there. The part is now properly clamped and we're ready to start drilling. To guide the hole, I'm using a 90-degree high-speed steel center drill. These holes do not need to be precise. I'm just eyeballing the center of the shaft. The only thing that needs to be the same on both pieces is the distance of the 2 holes. This is the first part done already, and now I'm just switching them. So far so good. Now it's time to drill the core holes of the 2 M12 threads. I just changed the tool bit, and the only thing I need to pay attention when drilling the holes is that they're not drilled completely through, because the slots of this milling table are 10mm wide, and because I have not centered it before, there would be possible to drill into the table, and I definitely don't want this to happen. So we're just going to drill 2 blind holes. Now I'm heading over to the drill press and drill the holes completely through. To realign the part, I'm clamping it in this vise in the prismatic jaws, and I'm just going down with my drill bit into the hole until the drill goes all the way down. Center the piece in the vise. And then I can just clamp the vise, and that's it. Now I can drill the hole through. Cutting the thread by hand is pretty simple. You just need to pay attention that this angle here is 90 degrees to the part, and I'm also checking from this direction if the tap is going in straight. Also applying some cutting oil. This looks pretty good, well aligned, and now I'm completely cutting it through. On these machine taps, it's not really necessary to break the chips. As you can see, due to the spiral flutes, the chips coming out very nicely. To remove this sharp edge here on the underside, I'm just going over it with a half round file. Now I'm just recutting the thread to remove the burr that we just made from the deburring. These 2 parts are now ready, and there's just the 2 long screws missing. I've already prepared these 2 threaded shafts, just cut them to length, made a nice little chamfer there on both ends, and now it's time to weld on 2 nuts on the end here. The screws are now ready too, and now it's time to test it. It's not looking too bad right now. The only issue right now is that this part on the left is just touching the movable jaw on one spot in the center there. Therefore it moves this way. So what I'm going to do now is I will take off material here on the bench grinder to make like a flat surface right here in the same angle as the movable jaw has. So I have a proper surface there. Also the part on the left, because it just has one spot that it lays on, it wants to roll away. And having this surface here will fix that as well. I just sanded away a radius like this. So instead of having just one contact point in the center, I now have two on both sides. Just putting the part in for a quick test. And it looks very good, sits very stable here, as well as the center drill looks pretty straight. One more thing, and I almost forgot to do this, I need to turn a pointy end on the screws so they're nicely guided in this part. To not damage the thread, I'm going to clamp it in a collet. But because I already welded the nut on, I can insert it like the regular way. I need to put it in from the back side and then mount the collet in a spindle. I've also made a little relief cut here, just the thread for sure doesn't get damaged when we're using the tool. This looks pretty good, and now we're actually ready for testing.